Hi guys, I'm live. I just want to do some nonsense, but it's not totally nonsense, but I just want to talk about music theory, but the music theory of notes and frequencies and math a little bit. Hope it's not boring. If it is, just don't watch, but if you're interested, here it is. So I Googled what is the frequency of middle C on a piano. It's 256 hertz. I thought that number is interesting because it just happens to be 16 times 16, and 16 is 2 to the 4th, so it's 2 to the 4th times 2 to the 4th, which means it's 2 to the 8th. So middle C is 2 to the 8th hertz. Now that means if you started at 2 hertz and multiplied it by 2 7 times, you would get because 2 itself is 2 to the first power, 2 to the 8th would be 7 octaves above the frequency that's 2 hertz. So if I had 2 hertz would be a very low C, and then 7 octaves above that would be middle C, 256, because 2 to the 8th power is 256. And that's interesting. A440 would then be the A above that. So middle C would be the G string of a guitar on the 5th fret, and then the A above middle C, which is A440 for 40 hertz, would be the 5th fret of the high E string. And I think it's interesting that we chose A440 as a reference point, because if we do the math, the most harmonious vibration to base A on is A. Let me think here. A432. Yeah, A432 would be actually harmonious, but somebody in Nazi Germany or something decided to make it A440 because it was just out of whack enough to annoy us, but not so much that we'll know something was wrong. So he just tweaked it just a little bit up from A432 to A440, and to this day we use it. So, but if you want to be pure and you have the real energy of peace and everything, you would actually tune your A to A432 slightly flat. But since everybody does it and it's on the radio and everybody's been doing it a long time, I just tuned to A440 myself. But it's good to be aware of those little number things. And then another thing I want to bring up. Wiseman's theorem talks about the number of books in the Bible and the number of keys on a keyboard, and it talks about 13 times 3 is 39. That's the number of books in the Old Testament, and 9 times 3 is 27. That's the number of books in the New Testament. The total is 66. Well, the same two numbers, but multiplied by 4. 13 times 4 is 56. 13 times 4 is 52, and that's the number of white keys on the keyboard, and 9 times 4 is 36, and that's the number of black keys on the keyboard. And I just want to talk about that for a second, how to know that intuitively without having to count the number of keys on the keyboard. Well, the standard keyboard is 7 octaves plus or minus a third, and the 7 octaves can refer to the lowest C on the piano to the highest C on the piano is 7 octaves. So there's actually 8 C's on a piano, which makes the expression middle C kind of an oxymoron, because there wouldn't be a single middle C, because there's an even number of C's on the piano, not an odd number. So technically there's 2 C's that qualify as middle C, and one of them we just decide to call middle C, which is kind of arbitrary, but it is. And to count the number of black keys and white keys on the piano is not that hard. Remember, you have a minor third below the lowest C, which would bring it down to A. So you have 7 octaves from the lowest A to the highest A. You have to have 7 octaves from the lowest to the highest B. And then you have 7 octaves from the lowest C to the highest C. You just got that 7 octaves plus a minor third. Well, one way of figuring out the number of white keys is you know that there's 7 octaves and from C to C, and there's 7 notes. There's 7 white keys per octave. So so that would be 49 keys. But you have the high key or the low key repeated again because it's octave. So you actually would have 50 keys from the lowest C to the highest C. And then if you have a minor third below that, you have a low B below that and a low A below that, and that's 2 more white notes. And 50 plus 2 is 52. That's the number of white keys on the piano. So you don't even have to count them to know that this is true. And then for the black keys, you know there's also 7 octaves. Within the 7 octaves from C to C, there's also 5 black keys for each of those octaves. And so since there's 7 octaves, and you don't repeat one of them because they're contained within the C. They're not. You don't start on a black key and end on a black key. So there really are 7 times 5 or 35 black keys within the C to C range of 7 octaves. But then you have the low B. You have the low B flat actually below the lowest C. As well as the B's, and the B flat is a black key, so that B flat would make 35 black keys from C to C plus 1, which makes 36 black keys on the keyboard, and that's how many you have. And 52 white keys plus 36 black keys make 88 keys on the keyboard. And the way I just explained it, you don't even have to count the keys on the keyboard to know if that's true. So I thought that was interesting, thought I'd bring it up. The middle C is 256 hertz, and that's 2 to the 8th power, or 7 octaves above a C that would be 2 hertz. It would be out of the range of human hearing, but it would exist. It does exist. Anything else? While I'm talking, I want to talk about some of my theorems and stuff that I tried to put on YouTube earlier, and it kind of blurred up on me, so let me just do some of it now. I just discussed Weismann's theorem. That 13 times 3 and 9 times 3 make 39 and 27, which makes 66, and that's the number of books in the Bible, Old and New Testament, and also 13 times 4 and 9 times 4 make 52 and 36, and that's 88, and that's the total number of keys on the keyboard, black and white and black keys. And then I just want to add, I want to go over once again Weismann's formula, which is 3 cubed plus 4 cubed plus 5 cubed equals 6 cubed. It's a 3-dimensional version of the Pythagorean theorem. And instead of having 2 terms on the left side of the equation and 1 on the right, you add a third term and you raise the power to 3. So instead of a squared plus b squared equals c squared, you have a cubed plus b cubed plus c cubed equals d cubed. And that happens to work for a equals 3, b equals 4, c equals 5, and d equals 6. So I think that's remarkable. It means that the volume of a cube, the volume of a sphere of radius 6 would equal the sum of the volume of a cube of radius 3 plus the volume of a cube of a sphere of radius 5 plus the volume of a sphere of radius. Sorry, I blew that. The volume of a sphere of radius 6 would be equal to the volume of a sphere of radius 3 plus the volume of a sphere of radius 4 plus the volume of a sphere of radius 5. And that's one application of Weismann's formula. Another one is if you go just like a squared plus b squared equals c squared applies to the lengths of the right triangle in 2 dimensions, you could use by third dimensional Pythagorean theorem, which I call Weismann's formula, to say that if you went 3 units in the x direction, 4 units in the y direction, and 5 units in the z direction out of the page, that point, the distance from that point to the center would be 6, and that would map out 3 dimensions because you're using 3 terms on the left of the equation, 1 on the right, and the power is 3. So they're cubed rather than squared numbers. And so I think that's interesting. Another thing, then I had Weismann's identity, which again is I'll say it again so I can document it. 6 to the 5th power, that's 6 times 6 times 6 times 6 times 6, happens to equal this 7776. So if you add 1 to it, you have 6 to the 5th power plus 1 equals 7777. If you divide both sides of that by 7, you get 6 to the 5th power plus 1, all divided by 7 equals 1111, or 1111. And I think that's interesting. That's Weismann's identity. Anyway, so I love you guys. Peace, love, and welcome.